What you are looking at right here is a photorealistic 3D rendering of an 8-ounce premium stand-up granola pouch suspended in midair. This output represents a precise, multi-layered structure. It captures the rigid outer shell, a transparent window panel, a mechanical zipper, and an internal barrier layer. For designers working in industrial packaging, standard AI generation often creates a recurring problem of structural hallucination. When tasked with technical design, models frequently generate geometry that ignores the physical constraints required for a production-ready model. To achieve true structural accuracy, the generative AI model cannot be used as an open-ended brainstorming tool. Instead, it must be treated as a rigid, deterministic system. Obtaining predictable, architecturally sound industrial mockups requires you to move past generic prompting. You have to build a heavily constrained, logic-driven pipeline. This flowchart illustrates the professional 3D mockup formula, mapping from product knowledge to prompt engineering and 3D visualization, governed by marketing psychology. Pushing data through this specific sequence overrides AI guesswork to yield a precise engineering visual for our granola pouch. The base of this pipeline, where all the structural logic begins, relies on Notebook LM to categorize and organize the initial data. Mastering Notebook LM logic frameworks is the prerequisite if you want to produce high-converting, technically accurate product mockups at scale. The first requirement is defining the precise visual output category. For our granola pouch, that category is the exploded view mockup. This comparison matrix highlights the specific structural demands of different mockups. E-commerce mockups, for example, prioritize a clean white background, specific viewing angles, and sharp zoom details for online catalogs. Lifestyle mockups require a different logic, focusing on placing the product in real-world settings, showing human interaction, and targeting emotional appeal. Advertising mockups shift the constraints again, relying on specific lighting, premium staging environments, and brand storytelling. Exploded views discard those environments. Their sole purpose is to expose internal components and execute a technical engineering presentation. Because of this requirement for strict spatial logic and layering, the exploded view is the ultimate stress test for an AI rendering engine. Explicitly locking in this mockup category is the first step in setting the architectural boundaries that stop the AI from hallucinating incorrect spatial contexts. With the category set, look at the split screen mapping the visual output on the left to the precise AI text prompt on the right. The physical suspension of the packaging layers is commanded by this specific spatial instruction regarding the vertical axis. The exterior texture directly correlates to this material constraint parameter. The internal protection visual is forced by the technical component constraint, and the clean background environment is locked in by strict lighting and resolution constraints. A single prompt requires a high density of specialized language to force the AI into this specific visual alignment. The core methodological problem is how a designer generates this level of prompt specificity without resorting to trial and error guessing. They don't write them from scratch. Effective technical prompts are generated by translating structured data matrices into syntax. The engine that translates raw data into that syntax is the Notebook LM logic framework. The first half of this framework is the product analysis matrix. This grid catalogs physical reality. The instruction for a heavy-duty zipper in our rendering prompt was pulled directly from the matrice's function node. The instructions for the craft paper and the internal barrier layer map directly back to the materials node, and the transparent viewing window was isolated from the unique selling proposition node. This matrix strips away creative guesswork, forcing the designer to quantify every physical specification of the product before interacting with an AI image generator. It acts as a safeguard, ensuring the underlying physics and engineering geometry of the final rendered object are correct. The second half of the framework addresses marketing psychology. This is the customer perspective matrix. The context for the organic granola inside the pouch was derived from identifying the target customer's purchase triggers. The eco-friendly visual aesthetic of the lighting and material was dictated by the desired lifestyle associations node. Standard 3D prompt engineering frequently produces commercially useless images because it ignores this psychological dimension in favor of pure geometry. Feeding customer psychology parameters into an industrial design prompt alters how the AI makes decisions regarding lighting, mood, and material finish. Combining the physical facts of the product matrix with the emotional triggers of the customer matrix creates a render that is technically accurate while simultaneously acting as a commercial asset. This funnel illustrates where the data filling those matrices originates. It all starts in the Notebook LM research phase. Raw, unstructured product specifications and dimensions are fed directly into the model to build the physical foundation. External data sets, specifically competitor analysis and customer reviews, are ingested to build the psychological profile. Internal brand guidelines and existing marketing materials are added to lock in visual consistency. Notebook LM acts as the foundational organizing brain. It distills hundreds of pages of disparate documents directly into the clean, categorized variables required by the AI visualization engine. When you feed all of those distilled variables directly into the prompt engine, you achieve a flawless and precise final assembly. The result is a commercially ready premium asset. The workflow is strictly linear. You conduct the research, populate the logic framework matrices, translate that data into AI prompt engineering, and execute the 3D visualization. This equation outlines the requirement for rendering success. Product knowledge, combined with prompt engineering, 3D visualization, and marketing psychology, yields high-converting product mockups. This pipeline scales because the underlying logic matrices, specifically the nodes for materials, dimensions, and unique selling points, apply equally whether the subject is a flexible granola pouch, a sodium silicate container, or the floor plan of a commercial property. By utilizing this deterministic logic framework, AI rendering transforms from an unpredictable creative gamble into a repeatable method for technical design accuracy.